All right, today we're pulling back the curtain on how these massive, complex software systems actually get built. We're talking about the blueprint, the real foundation of our entire digital world.
I mean, have you ever really stopped to think about it? How do huge apps like your banking service or your favorite online game get built by hundreds, maybe even thousands of developers without just completely collapsing into a chaotic mess? It kind of feels like magic, right? But it's not.
Well, the secret isn't just about writing a ton of code. Nope, it's the blueprint. It's this master plan that guides every single decision, every line of code, before anyone even types a single character. So let's dive in and figure this out. Okay, so first things first. We need to get a handle on what this blueprint really is. And the best way to do that? Let's use a super simple analogy. Building a house. So software architecture, that's the big picture. It's not about the little details, like the color of the paint or the style of the faucet. No, it's about the heavy-duty stuff, the foundation, the load-bearing walls, where the plumbing and the electrical systems are going to run. It is the absolute fundamental structure that everything else is built on top of. Okay, so you might be asking, what's the real difference between architecture and design? Aren't they the same thing? Not quite. Look, if architecture is the main blueprint that lays out the rooms and how they're all connected, then design is the detailed plan for what happens inside each of those rooms. We're talking about the specific algorithms, the data structures, all those nitty-gritty details. It makes sense, right? You can't really go pick out the sofa before you even know how big the living room is. All right, so why bother? Why spend all this time and energy on a high-level plan? I mean, why not just jump in and start coding? Well, just like with building a house, skipping the blueprint is a one-way ticket to a complete and total disaster. Because this upfront planning, it pays off big time. A really solid architecture gives you three absolutely critical benefits that are, frankly, non-negotiable for any serious project. And they all come from getting that master plan right from the very beginning. Okay, first step, it's a communication tool. The blueprint gets everyone on the same page. We're talking managers, clients, developers, everybody. It's a shared map so they can all talk about the project without getting confused. Second, it forces you to make the really big, important decisions early on. Things like performance and security, they're not just tacked on at the end as an afterthought. No, they are baked right into the foundation from day one. And finally, a great blueprint is reusable. Think about it. You can take that same master plan and build a whole neighborhood of reliable, similar houses. So, what exactly makes a blueprint good? I mean, it's got to be more than just drawing a few boxes on a whiteboard, right? Absolutely. It's all about applying some core principles that help you create a system that's strong, flexible, and, crucially, easy to maintain down the road. And the big idea here, the central concept, is something called modularity. The goal is to build your software out of these independent, self-contained pieces, or modules. Just think of them like perfectly organized rooms in a house, where each room has one clear purpose. And these modules, they need to follow what I like to call the good neighbor policy. The technical term is loose coupling. So good modules, the good neighbors, they're independent, they interact politely through the front door using their official interfaces. But bad modules, the ones that are tightly coupled, oh, they're the worst neighbors. They're constantly meddling in each other's business, climbing through windows, making a huge mess. And the result? If you change one little thing in one module, you cause a massive chain reaction and everything breaks. Now, the other side of that coin is a principle called high cohesion. This is pretty simple, actually. It just means that each module, each room in our house, should have one single, well-defined purpose. The kitchen module, it only does kitchen stuff. The bedroom module is just for sleeping. What you absolutely want to avoid is a module with low cohesion. That's the dreaded junk drawer module. You know the one, it does a little bit of this, a little bit of that. It's just a chaotic mess that's impossible to understand or maintain. Now, the cool thing is that architects don't have to reinvent the wheel every single time. They rely on proven styles or patterns. It's kind of like how a home builder might specialize in building modern-style houses or maybe classic colonial homes. So let's take a look at a few of the most common architectural styles out there. Okay, first up, we've got the absolute classic, client-server architecture. You literally use this every single time you browse the web. The easiest way to think about it, it's like a restaurant. So how's it work? It's really straightforward. You, sitting at your computer, are the client, or the diner. You send a request, like telling a waiter, hey, I'd like to see this web page. That request goes to the server, which is like the restaurant's kitchen. The kitchen gets to work, processes your request, and then delivers your order right back to you. It's this really clear division of labor that makes the whole system so efficient and organized. All right, next up is a totally different style. Peer-to-peer, or P2P for short. So I want you to forget the whole restaurant thing. This model is much more like a potluck dinner, where everybody brings a dish to share with the group. In a P2P network, every single person, or computer, is like a guest at that potluck. They're both a client, because they can take a serving of a dish they want from someone else, and they're also a server, offering up the dish they brought for others to share. What's so great about this? Well, it makes the whole system incredibly robust. There's no single point of failure. If one person has to leave the party, the potluck doesn't just shut down, right? The party keeps going. It's completely decentralized and it scales up beautifully. The more people that join, the more resources everyone has. Okay, last one we'll look at is called Model View Controller, or MVC. Now, this one's a little different. It's not about how different computers talk to each other across a network. Instead, it's all about how you organize the code inside a single application. The key idea here is a total separation of powers. So this pattern, MVC, it breaks an application down into 3 totally distinct jobs. This keeps everything super organized. First, you've got the model. Think of the model as the brains of the whole operation. It manages all the data and the business logic. Then you have the view. The view is the face. It's literally what the user sees on their screen. It displays the data. And finally, you have the controller. The controller is like the hands. It takes user input, say a click of a button, and then tells the model what to do and updates the view. By keeping these 3 jobs completely separate, developers can change the entire look and feel of an app without ever touching the core logic. It's a game changer for keeping complex projects manageable. So, you might be wondering, who's the person responsible for all this? Who is the master planner drawing up these digital blueprints? Well, that would be the software architect. And believe it or not, their job isn't just about being some kind of technical wizard. As this quote says, it's just as much about diplomacy, negotiation, and communication. It's really about people. A great architect has to be able to balance the needs of the business, the desires of the users, and the realities facing the developers. It's this incredible high-wire act of both technical and social skills. So really, they're the ones who have to understand the big picture. They make those crucial, high-level decisions, they communicate that architectural vision to the whole team, and then they have to make sure the final product actually sticks to the plan. They really are part engineer, part diplomat, and part mentor, all rolled into one. Okay, so let's wrap this up and hit the key takeaways. First and foremost, architecture is the blueprint. It's the essential high-level plan for any serious software project. And a good one does way more than just look good on paper. It actually enables success by making communication easier and locking in good decisions from the start. We also saw that the best blueprints are modular. They're built on that good neighbor policy of low coupling and high cohesion. And finally, architects have these proven styles like client-server or MVC that offer ready-made solutions for common problems. When you really think about it, this is the invisible structure holding our entire digital lives together. And as our world gets more and more complex, more interconnected, well, the blueprints we use to build it are only going to become more important. It leaves you with a pretty big question, though. What will the blueprints of tomorrow even look like?